Group 8 presents Glue, a social bot for multi-person icebreaker conversations. Glue is part of the Spring project with an overall objective of developing socially assistive robots capable of performing multi-user interactions. One of the open challenges for an artificial agent facilitating multi-user conversation is designing and implementing an appropriate interaction structure. We've addressed this challenge by creating the Glue bot capable of multi-user engagement. Glue's primary objective is to guide and facilitate multi-person conversations. Users can engage with each other using Glue's custom online chat room, with Glue as the host, guiding the conversation when required. We have also attempted to identify an appropriate icebreaker interaction design by comparing two contrasting interaction designs. These include the chit-chat interaction design, which is based on the concept of small talk, where Glue guides the conversation towards general interest topics such as movies, series, and music. In contrast, the game interaction design promotes human-to-human interactions through social icebreaker games such as Would You Rather and a quiz. Thus, using two avatars of Glue, the chit-chat bot and the game bot, we have evaluated our hypothesis that the game-based icebreaker bot is more effective in facilitating multi-user conversation than the general conversation bot. Dialogue management was the main challenge identified during the project planning stage. This included context-dependent Glue participation during multi-user conversations and multi-user sentiment capture. For example, as shown in the schematic, when the users engage in conversation, Glue enters an active listening state where the user's sentiments are captured. And when the user ceases to continue their conversation, resulting in an awkward silence, Glue breaks the silence by uttering an appropriate icebreaker dialogue to prompt further user engagement. In addition to the dialogue management, during the development of Glue, we also faced a significant challenge of intent misclassification. In our case, the stochastic nature of human-to-human conversations was the primary cause of the observed intent misclassifications.
This is our system architecture for the GlueBot, which is very similar to the architecture we presented previously. So we'll just briefly recap the main parts. So here are our two users. We have a chat GUI, which they both talk to, obviously on separate machines. A Node middleware service then sends those requests as HTTP requests into Alana. Alana knows about our Glue bot. It forms one of the ensemble of bots that Alana gets results from. Glue gives us results, which are then fed into the Alana selection strategy. And we've told this session of Alana to prioritize responses from Glue where possible, unless there's a profanity uttered or in one or two other situations. That text response goes back to the Node middleware service and is fed back to the user. So there's been one or two changes from our previous the first iteration of this. We've simplified in a couple of areas, and we've added this Glue reverse proxy as well, which actually allows Alana to talk to Rasa in a format that Rasa understands. But on balance, we found this architecture worked pretty well, and the thing that was particularly useful was it served as a platform for the tokenization system. We see here that there's tokens in the request and in the response, and this allowed us to solve this tricky problem of multi-user, multi-human dialogue, and we'll give a bit more information on that a little later. So this slide shows the details of the Rasa element, so the actual GlueBot itself. Glue uses a well-established NLU pipeline along with a fallback classifier to manage intent misclassification. Glue's NLU is trained for both user and response tokens generated by the user interface. The NLU intents are based on either general conversation or game-based interaction designs. The dialogue manager governs Glue's participation based on the response tokens, and the user sentiments are captured using user tokens. To solve the problem of intent misclassification, we have developed two kinds of dialogue management styles, and based on these styles, we have two types of Glue bots, the rule bot and the CSV bot. The rule bot has intent-specific custom actions along with default action to manage intent misclassification. In contrast, the CSV bot has a complete intent agnostic approach for most intents, except for profanity and exit. The CSV bot also uses the CSV file for scripted response management. These are the three key features of Glue. Number one, the two different interaction designs, general conversation or chit-chat and icebreaker games. Number two is Glue's online chat room with a custom user interface, which allowed us to implement the user and response tokens and also allowed us to link the Glue and Aligner bots to the user interface. And based on the dialog management styles, we also have two types of Glue bots, the rule bot and the CSV bot.
Now we will show you a brief demo of the ChitChat bot setup with CSV bot as the priority bot followed by Aligner bots. Users can connect with each other and Glue using the user interface. When the user clicks the connect button, they are assigned a unique user ID for the conversation. Users can initiate the conversation with hello, and Glue will respond with the first icebreaker dialog. As you can see, Glue does not respond as long as the users are conversing. When the users stop talking, Glue responds with another icebreaker dialog. From the example here, Glue has successfully captured that both the users are in Edinburgh. Similarly, Glue also captures yellow as the color liked by both users. Glue will continue to guide the conversation to general interest topics such as movies, etc. when required. Our robust dialogue management style allows the conversation to flow naturally, where the users can use contemporary lingo, abbreviations, as well as smileys. Next, we will show you a segment of the GameBot's interaction design where RuleBot is used as the priority glue bot. Both ChitChat and GameBots have the same initial icebreaker segment based on location, weather, and relational psychology questions. Instead of general interest topics, the GameBot facilitates multi-user conversation through Would You Rather and quiz games. As seen in the chat bot demo, Glue will respond only when users stop talking. Glue will ask users to cooperate with each other to answer the quiz questions. As seen in the admin panel, we can collect all the data associated with the conversations. The data include the tokens, responses, time, and participating bots. We have used these logs to carry out objective evaluations.
Behind the scene, we have a seamless integration of Glue's custom user interface and GlueBot. Each user is given an individual user token such as Human1 or Human2 when they join the chat room. The GlueBot uses this user token for sentiment capture. While the users are talking, the user messages are appended with user token and Glue keep quiet response token and sent to GlueBot. A 20-second timer countdown kicks in after each message is sent to GlueBot. If a user enters a new conversation within 20 seconds, the message is appended with Glue keep quiet token, sent to GlueBot, and then the timer is reset. Alternatively, when the timer countdown reaches 0, which happens when both users stop talking, the last message is appended with Glue response token and sent to Glue. We have two different Glue bots, the rule bot and the CSV bot. Both the bots respond based on response token extracted from user messages. If the Glue keep quiet token is detected, the bot will respond with silent message, which is filtered out and not displayed on the user interface. If the Glue response token is detected, the bot will respond with the next icebreaker dialog. The rule bot classifies intent and triggers an intent-specific custom action. To overcome the intent misclassification problem, the rule bot tracks and confirms the detected intent before dispatching the response dialog. In contrast, the CSV bot has a complete intent agnostic approach to solve intent misclassification. CSV bot sequentially executes the icebreaker dialogues using a CSV file for response management. Both the bots are capable of sentiment capture. However, compared to the rule bot, the CSV bot can capture common entities at every stage of the conversation. We have conducted between subject user studies with 12 participants to evaluate the interaction design and GlueBot. We have performed objective and subjective icebreaker evaluations by comparing two interaction designs. We have also compared the technical performances of the two glue bots. The top panel of the red box plots show objective icebreaker evaluations based on user logs. We find no significant difference between the two design patterns for human participation or duration of human conversation between glue responses. We do not see any significant difference between the two interaction design from subjective evaluations as shown in the bottom panel of blue box plots. Overall, majority of users thought that the time taken for Glue to respond with icebreaker dialogue was adequate, as seen in the bar graph. At a technical level, Rulebot had fewer errors in responding appropriately to the tokens, as seen in the top panel green box plot. The increased error rate seen in CSV bot may be attributed to unanticipated Alana participation during conversation.
Based on the user feedback, further improvements include improving the aesthetics of the Glue chat room. We can improve the user experience by giving the users choice between different interaction designs and Glue participation speeds. We have shown as a proof of concept that tokenization approach can be used to manage multi-user conversations. This approach can be further refined by changing the tokens and managing the timed response. We can also add the ASR element to the chat room to improve the user experience. GlueBot's refinement includes improving coherence and refining sentiment capture. Since the current bots follow a scripted style response, further refinements including improving the response's flexibility by activating learning approaches. This can also help in mitigating intent misclassification. We need to conduct more user evaluation studies to ascertain which of the two interaction designs has a better icebreaking potential. Finally, we need to refine the Alana participation by minimizing unanticipated Alana responses.
This slide shows the roles carried out by our group members. We've enjoyed working on this project and would like to thank the Spring 2 team for giving us this opportunity. We want to thank the Conversational Agents teaching team, Oliver, and especially Group 8 supervisors for their patience, continued support, and guidance. We would also like to thank all the participants who volunteered for the evaluation studies and the positive feedback on their Glue experience. Thank you for watching this video, and we look forward to questions, discussions, and feedback.